And here are answers to our next review quiz question. So here we need to calculate the volume of oxygen gas required to react with 3 grams of magnesium in a synthesis reaction that forms magnesium oxide at standard temperature and pressure. There's a lot of information in that question. We're going to go ahead and start with a balanced equation since we don't have one already. So a couple clues for our balanced equation. We have synthesis reaction, so I know that I have multiple reactants and a single product. That forms magnesium oxide. I know this is my product. Oxygen gas and magnesium are going to be my reactants. Oxygen gas and magnesium form magnesium oxide in a synthesis reaction. Remember that magnesium has a charge of +2 and oxygen has a charge of -2. So these guys are already balanced out. I don't need to add any more subscripts to this formula. But oxygen gas is diatomic, and so I've got this 2 here, which means that I have too many oxygens on this side and not enough on that side. We fix that by putting a coefficient in front of the formula. So now I have 2 MgOs. I've got 2 O's and 2 Mg's. I've got 2 O's and only 1 Mg. So we need to make that a 2. So we've got our balanced equation, O2 plus 2 Mg yields 2 MgOs. Next up, we need to figure out what kind of stoichiometry we need to do. So I have 3 grams of magnesium. This is going to be my given. I need to figure out volume of oxygen gas at STP. That's my wanted. We always start with our given. So 3 grams of magnesium. First step, always convert those grams to moles. The molar mass of magnesium on the handy-dandy periodic table is 24.305 grams per mole. So we have successfully gotten rid of grams top and bottom. I have moles of magnesium. As soon as I have moles, I can go ahead and flip my chemicals. I want to get rid of magnesium, turn that magnesium into oxygen. There's an invisible 1 in front of my oxygen and a 2 in front of my magnesium. So now we have successfully gotten rid of magnesium. It's gone. I have moles of oxygen, which is super close to what I want, volume of oxygen. So we need one more chunk of railroad tracks. I have moles on top. I want it to go away. I'm going to put moles on the bottom. We're going to flip those moles into volume. We measure volume in liters. Since it's at STP, I know that there are 22.4 liters in 1 mole. So now we can go ahead and cancel out moles, top and bottom. Liters, which is volume of oxygen gas, is all that's left, which is great because that's exactly what we want to find. So now we're going to calculate, and we can do 3 times 1 times 1 times 22.4 divided by 24.305 divided by 2 divided by 1. Or we can go 3 times 1 divided by 24.305 times 1 divided by 2 times 22.4 divided by 1. Either way, it's going to get you the right answer. 3 times 1 divided by 24.305 times 1 divided by 2 times 22.4 gives us 1.38243, so many decimal places. Let's go back and look at our given. I have 1 sig fig, 2 sig figs. I get to keep 2 sig figs in my final answer. I'm going to keep 1 to that 8. It's going to flip that 3 into a 4. And so our final answer is going to be 1.4 liters of oxygen gas.